No problem. Okay, so yeah, welcome everyone to this session on the data science project cycle. I can do a short round of introduction. I don't know how much you have shared beforehand, Kate, with the participants or not, but I can just briefly introduce myself. So my name is Svenja. I'm working as a data scientist for DHL Group. Yeah, DHL Group is one of the largest logistics companies in the world. Headquarters is based in Germany in Bonn. That's also where I'm based, but we have offices all around the world. And yeah, we have one central data and analytics team, which I am part of. But we also have different data science teams located around the world and also in the different so-called business units that DHL Group has. So yeah, but I'm basically part of the central team that supports the overall DHL Group with data analytics and data science topics. Yeah, if you have any questions in between, just yeah, ask them either. For me, it's also fine if you ask them verbally, but you can of course also ask them in the chat. Yeah, and I would say then we get directly into it. Um, and yeah, as said, this session is about the data science project cycle. And it's I mean, I guess many companies are doing their projects based on some frameworks and everything. And I think also if you normally think about any other project that you maybe do in your private life or in your academic life, you have at least some parts of structuring in the beginning, then you're working on it, discussing about things, and then maybe in the end you have a solution or implementation phase or something like that. So we are talking about such a more general structure that we are currently mostly trying to follow for our data science projects. And I hope that, yeah, okay, you can see the next slide, right? Yeah. Okay. And yeah, what we mainly try to follow is the so-called crisp data mining cycle. I don't know if you've heard of it or not. It's, I think, a common known industry standard. And basically, it's about kind of, yeah, first having business understanding, of course, which is very important for us because we really work on real world problems, right? And also, I mean, we are not just working on it for, I don't know, trying out the newest, fanciest data science models or whatsoever, but we are working mainly on them to kind of solve a business problem that we have in one of our business units or that, yeah, occur within the, yeah, DHL group. So that's, I think, one of the first important steps, the whole business understanding part. Then, of course, also always the data understanding part, which then also involves data preparation and modeling. And this always goes back and forth, right? I think seldomly it happens that you just get a data set, understand everything, data is perfect, and you don't need to get back to business or to anyone to understand the data better. So I think it's always a back and forth. And then in the end, hopefully you get to this evaluation and deployment phase. Yeah, but that's basically this overall concept of this crisp data mining cycle. And we will go now more in detail through all of those different yeah, steps or parts of the cycle. And yeah, discuss a little bit maybe which challenges we focus within DHL Group, within our team sometimes with the different phases and share also some examples or some knowledge and experience, but also happy for you to share maybe your experiences or also to share some best practices or yeah, just things that you experienced in different settings. So yeah, if we, for example, look at the cycle, how we kind of adjusted it a little bit to our normal project setup that we have within our data and analytics projects. So yeah, we also try to follow kind of an agile and cyclical setup, right? So that we always kind of review our results and everything, get back to business, challenge it with them. But in general, overall, a project mainly follows those 6 steps, I would say. Um, so, I mean, if we decide we go for a project, right? Or if we decide, okay, there's a business problem that's worth to kind of try to support or solve with data analytics, we will first go through this problem definition and scoping phase. Then, of course, also need to tackle this whole part of business problem process understanding to kind of make sure that we really understood the problem and know what kind of our goal for the solution is. Then third step is usually data collection, of course, data cleansing and pre-processing as well. Then usually this modeling step comes. I mean, sometimes it's real modeling, sometimes it's just more thinking about a solution, how to solve the problem, right, with the available data and all of the things that we know from the business. And then kind of moving on to this more pilot and implementation phase, which would then basically be the finish line or goal of the overall project to kind of then have an hopefully implemented solution that the business is happy with or that they can use to kind of solve their business problem. But maybe to before we go through the different steps of the cycle, let me show you one slide how we first kind of get to the project, because I think that's also, at least in business context, not that easy how to define projects and also how to kind of prioritize them and come up with the most relevant ones that are also possible to solve in a decent amount of time, right? You don't want to, or usually you don't want to work on those projects for 5 or 10 years, right? It's more something where you say, okay, I have a problem and it's small enough to solve it maybe with a proof of concept or something within a few months and not within, I don't know, 3 years or something. So that's why we have mainly, I think, I mean, there are also other ways how projects come to our team or to the central data analytics team within DHL Group, but we mainly have 3 different types of kind of streams that we use to get new projects or new ideas for projects. So the first one is, I think, or we call it analytics steering board. I think in many companies there are different decision boards, and we especially have one for analytics. So where all the data and analytics topics for the group are discussed, or at least the most important ones with high management attention, I would say. So basically, that's our analytics steering board, which kind of has also different sponsors of those different business units within DHL Group, and also the CEO is heading it. And there, of course, we also get some ideas or prioritization for especially the important data and analytics use cases. What we also offer in addition, and how we also get to know different use cases across DHL Group, are, for example, monthly use case cafes that we offer. So nearly everyone in the group could join if they have a data analytics idea or question or just want to discuss something. And then it's just an informal call, chat with some people from our team, and then we can discuss the use case, and if it seems interesting and we think it's possible to help them with data analytics, then we will of course have follow-up meetings which then maybe lead to a project or not. And in addition, we also do, for example, ad hoc workshops or use case ideation, where we then really sit down with the business for 2 or 3 hours maybe and really kind of nail down what their problem is and also how maybe the available data looks like and if it's from still high level view, but if we can already get a first idea on if it's possible to solve it or not, or to support them with whatever data analytics methodology would suit the use case. Yeah, but that's basically how we usually kind of get projects into our pipeline. And then, of course, depending on different availability of the data scientists, data engineers, and so forth, it then depends how many of the projects we can do and also which priority they of course have. Any questions so far on that or on this general setup of this project cycle? Then yeah, moving on maybe back to the cycle and going through those different steps that we usually go through with our data analytics projects. So the first one is, of course, problem definition and scoping. And I mean, I think that's very clear from the description, right? So first of all, we of course try to understand, maybe through workshops, maybe because we already worked with the business unit beforehand and already know that there are different other problems that we now want to support them with, right? So maybe we already have some pre-knowledge and everything, but usually in the beginning, we of course try to define the problem and also the aimed solution that we want to find, right? And also do some initial scoping, like saying, okay, maybe we first do a proof of concept of 2 months, for example, and then see how easily this problem is to solve and if we can come up with a solution, or if maybe the data is too crappy so that we cannot come up with a good solution, so that it's easy for the business and also easy for us to kind of have a very quick understanding of if it's possible to solve this problem or to support this problem. And yeah, just to make sure that we and the business have the same understanding and also the same goal in mind. And yeah, I think this is the typical first step that you go through no matter what you're working on, I guess. If it's like, it doesn't matter if it's like business context or academia or anything else. Then of course, after this, yes, you can just ask your question.
Okay. Hello. So I just wanted a quick one. So how can we apply this? Let's say in the context of when you talk of social development projects. I'm thinking that is this kind of similar to maybe when we're designing a proposal, maybe at a proposal development stage, and then maybe you are looking at the data, looking at the problem, and looking at trying to look at the supporting data. I mean, is it how similar are they? Is it one and the same thing, or?
I think it's very, I mean, I think from my opinion, I think it's very similar no matter which problem you tackle. If it's one, right, for DHL group, if it's one in academia or if it's one for analytics for a better word, I think it's always the same thing, right? First, you need to understand, okay, what's kind of the problem and what do you want to solve, right? Or what should your solution kind of, yeah, provide to kind of your stakeholders, right? Whomever they are, if it's a professor at university, if it's, I don't know, some vice president at DHL Group, or I don't know, Red Cross in whatever country, for example, right? And then you need to first understand with them, okay, what's the problem? Define kind of the scope of the solution, at least from a high level, right? I mean, this will always change. And after you've looked in detail into the data, you will maybe find out that some things won't work for whatever reason. So I think you will always need to come back to those stakeholders and kind of discuss with them what's still in scope and not in scope, right? But having initial assumptions and saying, okay, this is how you understand the problem. This is what the solution should kind of solve. And then this is the data that you will get provided, at least from a high level, I think is very important in this first stage, to then also kind of be able to scope it a little bit, right? To say, okay, to maybe come up with a first approach or an idea, and also maybe have some very minimal model, for example, to solve it, to just have some baseline and see if it's even worth getting into the details or not, I think is very important in the beginning. And I think it doesn't matter if it's, yeah, in which context you do that, to be honest. But of course it always, yeah, sorry.
There's a question in the chat. What is data in your organization, and what types of data do you typically deal with?
So I'm not 100% sure if it's more meant on a technical, like in which way we store it or whatever, but data can be anything, right? So data can be, for example, if you want to forecast the parcel volume in the US in certain, districts, for example, for the next day, then of course you need the historic parcel volume data, right? That we have, for example. And this is then stored, for example, in some database or whatever. So this can be data, but of course we also have data like, I don't know, customer service complaints, and then it's not numeric data, right? Like volume numbers or something, then it's maybe more text data that we then analyze. So it can be very different depending on the use case. I don't know if that answers the question or not.
I think it does.
Yeah.
There was a thumbs up. One more question in the chat is, can you tell us some typical examples of problems identified in different types of scoping sessions?
Yeah, so we have worked, I think, so far on many different use cases. So one very prominent, or also I think obvious one, right? I mean, DHL Group is also very much into, kind of shipping parcels or products for customers all over the world, right? So of course, volume forecasting is a very important use case. Then also use cases like routing optimization or network optimization are very prominent use cases. And they can go from a very different scale, right? I mean, it can be that just one business unit or one country says, okay, I want to have a routing solution. And then we try to figure out specifically for this country what makes sense and everything, because it can be very different from country to country, right? And also the different business units can have different operating models. So it can be very tailored and narrowed down to one country, for example. But it can also be, for example, we also have a tool that does for customs automatic product classification, right? And customs is, of course, a problem for many business units and also for many services that we offer. And there it's more a generalized solution that can then be used by different business units at the same time. So it's always very different depending on the problem that we want to solve. And it can be rather small in that sense that it's only tackling a specific country, for example, or only a specific product, or it can be very global in that sense that it's maybe something that we can offer for all of the business units.
And
I hope that also answers the question.
Yeah, the last question is, do you have forms or procedures that you usually fill to define the problem when you're defining the scope?
So we usually, in the beginning, we already know a little bit in which direction the problem will go, right? So for example, for volume, if somebody comes to us and says, okay, I want to know, or I want to plan more accurately, and I want to know with how much volume I need to estimate for next week or whatever, right? Then of course, it's clear that it's more a forecasting project, right? And then already in those first scoping workshops that we have, we usually then do the workshops with people that mainly worked on forecasting and those kind of things, or also with people who maybe already work with the business unit, so that we kind of get already a better feeling in the beginning and don't start from scratch, I would say. But but it's not like that we have one predefined form or something that you need to fill out. So usually we have the scoping workshops then specifically for the specific problem. So it's not that we have just a form that you fill out and then there's a standardized process or something that goes around it. It's more, I would say, usually very tailored to the problem.
That's all the questions for now. Thanks.
Okay, perfect. No problem. Yeah, so I would say that's at least it on this first part of the cycle. And yeah, as I said, I think it's yeah, very dependent on the problem and everything, but I think it's important to first have a general understanding and already scope a little bit so that you know kind of, and also your stakeholders know what to expect. Then moving on to this more business problem process understanding. So this goes, I think the first part is more on understanding high level the problem and what could be solution methodologies that you can use, right? And then scoping a little bit, okay, is it rather a POC of 2 months or something, or is it something that already will take years because it's, I don't know how complicated. But then this business problem that understanding that comes afterwards is more really detailed understanding, okay, what do we need? How can we provide it to the business and everything? And for example, we had a use case where we also wanted to predict the delivery time window to the customers, right? And then we need to, of course, understand how can we, on the one hand, of course, predict that, but also on the other hand, how shall it later be communicated to the customers? How exact do we need to be with the forecast and those kind of things, right? And those are all things that we try to kind of understand together with the business stakeholders. Yeah, and this, of course, always goes back and forth, right? I mean, it's not that in the first meeting you will understand everything, but after that, you will get data, you will go through the data, you will also go through the process with them again and again, and then you always understand a little bit more, a little bit better what the whole topic is about. And what we, in addition, always try to do, if it's possible, I mean, it always depends, right? But that we also, for example, if we do this routing optimization, then of course it's also useful if you maybe once or twice go on a tour with an actual driver that delivers the parcels, because then you also know what his work or her work is about, right? And you understand, okay, what's the problem? What are maybe things that you don't think about because I'm usually working at my desk and not as a delivery driver, right? So that's always something that we also try to do in that phase very early in the beginning to already understand the process also better. Okay, then I think comes the phase that is always a little bit, yeah, not critical in that sense, but yeah, where we just depend a lot on the data that will be provided to us, is this whole data collection phase. And yeah, I don't know from your experiences, but this one can be sometimes very easy because stakeholders already have all the data and know where it is, but can also be very hard and maybe take a long time. And yeah, so we have use cases where it's maybe more a topic of weeks or days to get the data and to get access to it, or it can be a topic that takes months. And maybe to show that based on one of our examples. So for example, for Post and Parcel Germany, we provided a letter volume forecast. And for this, we needed kind of different data. We needed, of course, operational data, right? But also, I mean, that's very specific to Post and Parcel Germany. But we also needed announcement data. So customers of DHL, large customers like Amazon or whoever, can announce their volumes. And that's, of course, also very helpful for this volume forecast, right? To kind of also know what large customers announce as volumes, because then you can incorporate that already beforehand. And of course, this is, could be a helpful feature for this forecast. And we also needed this announcement data. And the ops data was quite easy, so that they had all the databases, they knew how we could get access. But this whole announcement data was a topic that took months to kind of get access. So we first received some manual Excel reports and those kind of things, try to work with that. Then we also had different meetings with data owners, try to use the data that they mentioned, and so on and so forth, right? And then at some point, we met the right data owner, defined the solution, how it should look like. They would need to set up specific queries for us. So it was not that the data was already in a format that we could use, but they would need to kind of use their raw data, aggregate it to a certain point, and then provide it to us. And this already, like this whole process, for example, took months, or in this case, even a year. So it's not that always, even in a business setup, those things are like done within, I don't know, hours or weeks. But even in those cases, it can take months or even a year until you have even the data in the right way collected. And I think this is just something that is important also to consider in this problem definition and scoping phase, right? If you know that certain data like this ops data is easily available, then you can just say, okay, fine, we know it's available, so this part won't take that long, right? But if you already know, okay, nobody of the business stakeholders knows where this data is, if it even exists or not, then you can already plan for more time. And I think that's always a problem that we as data scientists struggle a lot, that this can sometimes take very long, and then of course also postpone our part on working on the data by maybe even months or years. Any questions to that, or any comments from your experiences?
There's one in the chat. The question is, in what stage do we do a feasibility study? We might define a problem, then realize that there's no solution available for the moment, lack of data, problem too complicated, etc.
So it can happen at different stages, right? And I think that's also always what we try to do, to have different review points within this whole cycle to then also, take those decisions, right? Of not going forward because it's maybe not solvable, or the data is not good enough, or whatever reason. So I think usually we try to do those POCs, right? So proof of concept. So we would say, okay, maybe in this case, we would already know, okay, the ops data we have, but for this announcement data, we maybe in the beginning only have CSV files or Excel reports, right? Then we would say, okay, because it's not worth to take this 1 year to kind of get a solution for this announcement data if we later figure out that either we don't need the announcement data, or our model won't be good enough to have a high accuracy. So then, of course, it's better to first take this ops data and take those CSV reports to come up maybe with a first modeling approach. And if this one is promising, then you would kind of take this decision, say, okay, we also need this announcement data in a proper way and not just via CSV reports or something, right? And then you would go through this phase. So it's not always that it's like one consecutive line of steps that you go through, right? But that you always can go back and forth depending on the problem, the data, and everything. But that's how I would do it for this specific use case, right? To first use those CSV files, maybe have a 2-3 months POC period to come up with a very basic model, and only explore a few of the features that are possible, and then see how good you can already be. And if there you already see that, I don't know, you will never end up with a good accuracy, then it's not worth getting into those data details or working further on this topic, right? So I think that's always important to consider. Yeah. Any other questions? Then
Nope.
we can, okay, perfect. Then we can move on to the next step of the cycle, which is data cleansing and pre-processing. And yeah, this one can also take a while, depending, of course, on the data quality and everything. And also this whole, usually in this phase, when you get the data and then you start data cleansing and everything, you always go back and forth a lot from the fourth step to the second one, right? Because you will see things in the data that you don't understand. Then you go back to business, ask them, here I see XYZ. Sometimes they know what the reason for that is, sometimes not, and you need to figure it out together. But through this back and forth, you will always understand the whole problem better, and also how you can maybe even clean the data better to come up in the end with a better solution. Yeah, and I think there are, at least for, I mean, what you would normally consider, especially from machine learning or time series forecasting projects, very typical things are that you, for example, in this example that we talked beforehand about this volume forecast, you would look at the different time series, for example, for the different years. You would check, are there any anomalies that you detect? Can you maybe get rid of them? How to impute them? Do you take the mean, the median? Do you fit a model for imputing? Whatever, right? Or is there some business logic that you can do? Yeah, so those kind of steps you would usually do, of course, also depending on the data and depending on the use case. But for this example, you can see, for example, I mean, it's always a very typical seasonality that we have. And for parcel volumes, at least, and it's very typical also for letter volumes that, for example, at the end of the year, you have a peak because of Christmas, right? And then after Christmas, it goes down quite a bit. So that's like, yeah, normal seasonality that you would see. But in this example, you can see, for example, that this year, 2015, so this red line here, somewhere in summer or mid of the year, seems a little bit odd in comparison to the other ones. And then you would maybe go into the details and check what's the reason for that. And then it might be that you figure out that there's one letter center. So Post and Parcel Germany has different letter centers all over Germany. And this one was the accumulated sum, right? And then you would maybe look at the different letter centers, and then you would figure out that one of the letter centers maybe, yeah, had here a dip for whatever reason, right? You would maybe go back to business, ask them, is there reasons for that? Were there some problems, whatever? Maybe they say it was on a lower capacity for whatever reason. And then you would try to come up with a solution how to clean that part of the data, because it's not yeah, it's an outlier, and that's not something that you want to use later as input for the forecasting. Yeah, and that's basically, right, those are, I mean, it's not as easy as now, yeah, telling it to you in 5 minutes or something, of course not, but that's typically this whole data cleansing state or part of the cycle, where you just, yeah, go through the data, look at different angles, look at different things, see if there are missing values, see if there are outliers, if there are business reasons for those kind of things or not. And then you try to, yeah, clean the data so that maybe those outliers don't later influence your forecast or whatever model you want to use. Okay, and yeah, also I think which is very important is that I think usually, at least for me as a data scientist, or also I think for most of my colleagues, this data cleaning, data preparation phase is most of the time the phase that takes very long, and that also is maybe not the most motivating or interesting one of a project, but it's a very important one, right? The better you clean your data, of course, the more accurate your models, your algorithm can be data, and the better your solution later will be. And also, the more you look into the data, the more you will understand the whole problem and the whole process. Yeah, but I think it's usually not the phase that, yeah, we enjoy the most, or that is, yeah, the most excited part of a data analytics project, I would say. Any questions to this data cleansing, data pre-processing stage?
Sorry, how do you standardize the data cleansing tasks? Do you make process, or it is something that's customizable for any kind of data?
It depends a little bit, right? I think usually, of course, there are standardized explorative data analysis things that you can do, right? And there are also libraries for that, for example, in Python or whatever language you are using. So I think that's definitely something that we usually use, right? And we, for example, also have some example Jupyter notebooks or code that we can use from other projects to kind of then adjust it to a specific use case. But typically it's very much adjusted to the different use cases, because just the data is not in such a big company with, I don't know, working in over 200 countries, it's just not that standardized, to be honest. And therefore, also for this whole data part, usually for the use case, you need to have a dedicated solution for each of the use cases. I mean, you can do basic steps, right? That like finding out, of course, where you have missing values and those kind of things. But still, I think how you then do it for the different use cases is always a little bit different, to be honest.
I want to ask, like, as a data scientist, are you, or is the data science is the first point of contact of the data from the source, or there are some processes that happen on the data before it reaches the data scientist? And
it depends always, right? I mean, it also depends a little bit in which direction you're going. Like if we are talking about our project, then usually the data scientists are the first people who get the data and then see what they can do with it, right? But so that's usually the case. So there's no one beforehand that usually takes care of the data. But of course, if the data is, for example, out of a certain database or something where already some cleaning or some logic is happening, then of course this happened beforehand, right? But then this is more something that's already there, not because of our use case.
There's a lot of questions in the chat.
Okay.
So let me read them off for you. Shola would like to know, for an organization that is just coming up with data collection structures, should this be set up to proactively overcome these data collection challenges you highlighted?
I think it always depends on the size, right? I think if you're a very new company that doesn't have that much data or IT system legacy, I think it's definitely worth to think about that beforehand, and to also think how to easily structure your data so that it's also easy to analyze and access, right? But if you're like a company that basically the origin is 500 years ago and you have, I don't know, IT systems that are maybe 20 or 30 years old, then I think it's just, I mean, it's a nice goal to work to, right? But it's just, I think, not realistic to have that if you have like, 300 or 500,000 employees around the globe and data for over 200 countries and I don't know how many different products. So I think they're just not possible, or it's hard to achieve. But if you're a very new company and you can really now define your IT infrastructure and those kind of things, I would definitely recommend it.
The next question is, what would be the best software for data cleaning, if any? Is there a preference as to which type of data will need to type of cleaning software, Excel, Stata, etc.?
So yeah, so what we mainly, but it's also a decision of the team, right? So we mainly use Python for all those parts, like usually for the whole kind of cycle, depends a little bit, but mostly we use Python because we also need to make sure that if, I don't know, I leave the company or I get sick or whatever, that someone else can take over, right? And if everyone would use different tools, that wouldn't make sense. So we mainly try to use Python or Python code. But of course, on the data part, it can be very different, right? If it's an SQL database, if it's more Kafka topics or whatever. So there it can be very different solutions depending on the IT system. And also some part, if we, for example, figure out we need to do a certain cleaning step or aggregation step, that would make sense to do it on the database and not within our solution, then of course, this is something that we try to then discuss with the business and move to the database, and then it's done on the database or on the data storage, no matter which storage type it is.
I'm going to combine some of these questions because they're quite similar. So the question about around data quality and data checking, is this embedded in the process? Where is the line between data cleansing and data manipulation? And how do you split up the data cleansing tasks between your team members?
Yeah, I think the question with data cleansing and data manipulation is a good question. I think it's hard to draw a line there because, I mean, I would consider data cleaning rather something where we say, okay, we have, I don't know, missing values or we have outliers and those kind of things. And data manipulation is really more if we need to add a lot of logic to the data to make it work. And I think usually you should never do manipulation because, or you should not, kind of manipulate the data too much, because then in the end you might end up with a model that is working maybe for this manipulated data, but not maybe for the real data that you will receive in the future, or that at the moment at least describes the current status. But yeah, I think it's hard to kind of have a line between those two things. And I think the other part of the question, which was, can you remind me again? It was not about the difference between cleaning and
splitting up the tasks
just in the team.
The team.
So it depends always a little bit. Usually we have teams that are rather small, so maybe 2-3 data scientists working on it. And then, of course, it depends a little bit. We always try to then have different chunks of different parts of the data, maybe going to a different person or people looking into different parts of the data, right? Maybe someone is more looking into the data and how to clean it, but someone else is maybe already thinking about, if we're talking about forecasting or machine learning, about features that we could use. And then maybe another person is already checking, okay, which models could be used. So can be that we split it by that, or can also be that we say, okay, if we have different data sources that we need to clean or get our head around, then maybe we assign the sources to different people. That's how we usually do it.
There's some questions around, so do you have any forums, repositories where you can go to check if you encounter data cleaning challenges? Same vein, do you have any documentation on this? Do you document the steps taken during the data cleansing? And if so, can you share some best practices?
So we basically we have a shared GitHub with the whole team, and then for each project we have a repository, right? So everyone can access, at least read those different repositories, and can then of course also see if there are some best practices or go back to other use cases and refer to them. So, and there we also do the major part of the documentation. So I think it's always important on the one hand to, of course, document your code, right? Or comment your code. But then we, of course, also always try to have proper README files and everything that explain also the reasoning behind the code and everything. And I think that's, yeah, also a lesson that I think you always learn, I guess, after some time is that, yeah, proper documentation really helps you to speed up for then the next use cases, or also maybe your colleagues when they need to take over or want to get back to your code, to also help you not to always get asked questions because you did not document properly. But that's how we usually do it.
What are the potential risks of linking data sources? At the end of the day, they are the data.
So I think it always depends, right? If for a certain use case you need to link data sources that weren't linked before, and you need both data sources, I think it's worth to do it, right? But of course, I think you always need to just take this decision. Is that something that we should do for this use case, right? Putting together and joining data, or if it's more something that we should do on the data side. And I think this just depends. If it's only maybe one single use case or a smaller one, then I would do it on the use case side. But if it's a bigger use case where it's also maybe better from a resource perspective to do this whole data part on the data part and not within the use case, then I would always go for, or try to go for that.
And then the last question is, which Python environment do you work with most? Spider, Visual Studio, PyCharm?
So we mostly work with Visual Studio because we use Kubeflow as our kind of, for example, server and so on. And there it's easier to work with either Jupyter Notebooks or to work with Visual Studio. But for use cases like then we use Visual Studio because I mean, Jupyter Notebooks we would maybe more use for EDA in the beginning of a project.
That's all the questions for now.
Okay, perfect. Then I try to speed a little bit up to make sure that we can also go to the 5th and 6th date of the cycle before we have 4 p.m. Okay, then maybe to the step that I think is usually for us or for data scientists the most exciting, or one of the more exciting parts, I would say, is the whole modeling phase. And I think here I don't want to go into all of the details, right? It really depends on the use case and everything. If it's a forecasting use case and you want to use machine learning, if it's maybe a clustering use case where you also want to use some clustering algorithms, if it's route optimization and you need to come up with a heuristic or whatever. So I think this always depends on the use case. But what I think is a typical, not mistake, but I think usually because of maybe backgrounds that a lot of us have, which is usually academia, and then you're always caring about or you're sometimes caring a lot about the model and how sophisticated it is and how much you can tweak a model and so on and so forth. I think you get sometimes lost in that, or it can easily happen. But I think on the other hand, it's more important not that you have the most sophisticated model or anything. Sometimes even a simple model can do the same trick or have a nearly same accuracy. And it's more about this whole data cleaning and data preparation and selecting the right features beforehand. And this is, I think, the important message that I just want to convey for this modeling part, that usually it's very important to choose the right data, choose the right features, choose them in the right way. And then it doesn't matter so much which model you use, or you don't then need to, I don't know, get into all of the details of the model or the logic, because usually it's more important to have good data or to put your data in a good shape so that then even with an easy model or with not putting too much effort into a model, you can achieve good results. I think that's an experience that we usually make, and that is maybe a little bit different from what, maybe if you're starting as a data scientist, you're more taking or thinking about those models and everything, or different algorithms. But I think that's not the most important part of the overall task. And this is just one example of a churn prediction project that we did, where we really cared a lot to kind of select the right features. And then we just did a simple random forest, nothing spectacular, to kind of then have a good outcome or a good accuracy. And also, I got one example from Analytics for a Better World, right, where it's also very important that you kind of use the right features and everything. And then it doesn't matter. I mean, it still, of course, can matter which model you use, right? But I think this is more important to care about the features and everything than caring about the most sophisticated model. And I think that's the important message about this overall modeling step. And also I think what is important is that this modeling step is usually, it's 1 out of 6 steps, right? And it's usually also 1 out of 6 steps that doesn't take, I don't know, maybe a year, like getting the data or something, but it is usually much quicker in that sense that it's not the major part of an overall project. Any questions to that, or okay. Then maybe to the last part of the cycle. So of course, after you did the after you understood the problem, you got the data, you cleaned it, you came up with a good model that has promising results, and you aligned everything with business, of course. I think this is also one of the more exciting parts. You try to either put it into a pilot or even already implementation phase. Can be also sometimes painful, right? Because maybe you will encounter bugs and errors and certain ways why something is not working. But I think it's also always very exciting to then see that something is working in production, or people are actually using your forecast, or following the routes that you are proposing to them, and those kind of things. So I think this is one of the more exciting parts. And as I said before, the modeling or machine learning part is only a small part of a real life analytics solution, right? So you need to think about a lot of different steps. Also, this implementation is usually not straightforward, because usually you need to communicate with different systems, need to provide interfaces to them or whatever, which is not that straightforward. So only a small part about usually our real life analytics projects is about coming up with the algorithm as such, or with a model as such. But I think that's also typical for most of the real life applications of data science or data analytics. And that's
There's a question. Talk could be considered for modeling.
What do you mean with
POC?
POC, proof of concept, or
they wrote T as in Taylor, TOC. I'm not sure. Maybe Paul, if you want to clarify the question. Theory of change be considered for modeling?
You mean with what? I'm not 100% sure, to be honest, what you mean with theory of change. Maybe you can elaborate.
In social projects, we normally come up with theory of change. Like, we intend to come up with a solution that, in the event that we do certain interventions, will obtain a desired outcome. So when modeling, could we use the theory of change? That's my question. I don't know whether you understood it.
So I think, yeah, I mean, of course, in modeling, you can kind of, I mean, right, if you always have this part where you say, okay, that's how you, or kind of you have a solution in mind, but if you decide for whatever reason you need to change something or need to adjust to a certain different assumption or whatever, I think you can always, this can always happen. And I would not say that typically can only happen or you can only be solved in this modeling phase. I think it can also be solved in the other phases, but I think it's overall important to kind of be open to change as such, right? And to kind of always with the stakeholders define if this is what kind of provides a solution to them or not, and what needs to be maybe changed or not. I hope this goes in the right direction. I'm not 100% sure if I understood it correctly, but yeah. And I think also the solutions should always be set up in a way that you can easily change stuff, right? Or change logic. Okay. Any other questions?
In a lot of cases, when you have a successful pilot presentation of the solution, they bombard you with new features that they would like to implement, leading us to an infinite feedback tool update phase. How do you ensure that you prevent that from happening and actually launch the model on time?
Yeah, so I think this is an important part of the problem definition scoping part. And I think you always need to go back to that part, right? This will always happen that people, if they see that something works or that they always want to add stuff. And I think there it's just important to have expectation management and also say, okay, that was the scope. Let's maybe first get this on the street, right? Make it work. And then we can later see if we want to add things or not. So that's how we usually do that. And of course, I mean, I think that's at least easier in a business environment. There's always time and money involved, right? So usually it's easier to say, I mean, there's always a trade-off. So they will never come with stuff that will take months or years to implement because then it will prevent them from having the solution. And they would always need to pay money for it. So I think that's a natural stop to that, at least to some point, but still this happens, right? And I think it's just important to set expectation to always come back and say, okay, we defined that scope, we go live with that, and then we can see if there's still something that we add, but do it in a more agile way to kind of already start with a certain product and not first build a full-fledged solution.
Do you agree that data cleansing, modeling, and implementation could be recursive, especially in social and humanitarian context in which we depend on the same data and reuse it again and again for different outcomes?
Yeah, I think definitely. Like if you have use cases that depend on the same data or answer the same questions for different use cases, right? Then I think you can definitely learn from other projects and you could kind of use the same approach or similar approach to kind of problems that are also the same or go into the similar direction. So I think that's definitely something that's worth to explore, right? To have more standardization to the different steps so that you can easily reuse things.
That's all the questions.
Okay, perfect. Then in the interest of time, so since I mean, from my side, we are done with the cycle. I think I would have had a few more slides, but it's nothing major, just adding some information to some of the topics. I think, yeah, overall, it's important that no matter which problem you look at, I think usually you go through those stages, maybe not always in all of the detail. And of course, maybe some projects don't have some parts of it, or maybe you don't need to go that often back and forth between the different steps. But I think in general, it's just important to keep this basic setup in mind, and also to keep especially this business and problem understanding in mind. That I think this is key to also have a smooth project if you understand the problem as such very well, and also have a good relationship, or try to have a good relationship to the stakeholders, so that you can always come back to them with different topics and questions.
Sorry, there is a documentation part as well to the process.
Yeah. So yeah, we didn't highlight it in that way. It always is something that we do on the go. So usually, for example, when we start defining the problem and everything, we would already document on a high level what our understanding is. Then when we go through business problem and so on, we would detail that more out. When we do data collection, we would kind of document a little bit how the infrastructure looks like, which data we get, and so on and so forth. So I think it's more something that you would do, or ideally you do in all of these stages, and it's not something that you would just do in the end or something. Or that would be my recommendation, I would say, for the documentation part or documentation step.
And just to confirm, the slides from today will be posted to the GitHub repo.
Yeah, I will put it to the GitHub repo, and I will just upload it as a PDF if that's okay. But I guess it should be
perfect.
fine.
Yeah.
Yeah, I will
Awesome.
do that directly after the call.
Thank you. And I wanted to just let everyone know that after each of these sessions, we ask that you complete a survey just to provide your feedback. I've dropped the link in the chat, so I'll also post it in the Slack channel. But if you can please take 2 minutes sometime today while the session's still fresh and provide your feedback. Then I would like to thank you for joining, and thank you for the information that you provided to us.
Yeah, sure, no problem. And happy, I think you also provided the contact details, right? Or yeah, always feel happy to reach out if there are any questions. Okay, then have a nice day.
Thank you, everyone.
Bye.